As Wendy mentioned, the topic of my talk is technology innovation, 3D printing, and multi-rotor drone technology. Let me give you a little background about who I am. I am Stephen Forney from Huntsville, Alabama. The sign in ASL for Huntsville, Alabama is an initialized H hand shape, which looks like a rocket. And in all of Alabama, Huntsville is the only place that you'll find people with German accents. Interestingly enough, the grandparents of the current generation immigrated from Germany to Huntsville and were key in starting the rocket research that Huntsville is named for. I studied here at RIT and received my Bachelor of Science in Electrical and Mechanical Engineering Technology. I have approximately 10 years working in robotics and interns through the University of Alabama at Huntsville. I'll sometimes refer to it as UAH. The department I work for at the university is SMAP, which is the largest center of the university. It's the Systems Management Product Center. The 10 years that I've spent in my research and my learning has led me to my current position as a research associate, and I am pursuing my master's degree in human-computer interaction. Now, before I continue with my presentation, I want to talk about a freak thing that happened in Alabama last Wednesday and Thursday. Now, for people who are here in Rochester, we're used to the snow, and we're used to inches and even feet of snow. However, in Alabama, it only takes one snowflake. It's one snowflake and the world is shaken. You know, we don't have the resources in the South like you do in Rochester, and so one snowflake deems us unprepared. So I wanted to start this evening with a joke. And look at the picture, and then look at me, and people will ask, what happened to your hair? And I will say, you have to talk to the people in cast, because I had a full head of hair when I arrived here in the SVP class of '05. I was one of the founders of the e-bike program here at NTID, and that happened my first year here. And when I got here in '05, I was astounded at the opportunities that were in front of me, and I wanted to participate in so many things. Electronic bikes seemed so interesting. It was the hot topic, and I was thinking, could bicycles become electronic? I didn't quite understand that. And so I decided to participate in this group. It was a great experience. The bikes that we built from scratch. We donated, we got some donated parts, and we entered a competition. The competition was against a few colleges as well as professional groups, all e-bike enthusiasts. We won first place in the student division and second place overall. That was great, and it was an inspiring experience for me as a young student. After the Electric Bike Club experience, I decided that I was going to major in automation technology in my associate's degree. Before I continue, I want to talk about the four circles of knowledge. Automation technology completes my first circle of knowledge. A few years after I was in automation technology, learning about robotics and control systems, I learned about troubleshooting. My knowledge and the investment of my time was worth it because I found my first internship at SMAP. And I didn't realize that it was located at the University of Alabama in Huntsville. And I was wondering what was so special about that, and it was because it's one of the largest research departments within the university. Not to mention that right across the street from our SMAP Center is the Cumming Research Park. That's the second largest research park in the United States. So I felt honored to be a part of this program. Also locally, NASA has a large base as well as the Redstone Army base. So the heart of Huntsville is research. During my first internship, I was assigned a project that was called the autocopter. And I had never heard that word before. The size, it was a huge copter. The blade itself rotated about 70 degrees laterally. It was quite large. And you controlled it through computer remote control. And as I walked around the autocopter, I couldn't take my eyes off of it. I was amazed at how you could control such a device. So that was the autocopter. Now we wanted to automatically be able to control the autocopter. And I had to enhance my skills, and I had to practice my own ability to fly helicopters by buying an RC helicopter kit. I built it out of the box. I was very excited. And as I connected the engine and was ready to take it on its first flight, and naturally, I didn't understand how to control all of the controls on the helicopter. So I flew it once. I didn't think it would be that tough. The takeoff made me feel confident enough that I knew what I was doing, and I was flying it down the runway. And as I wanted it to land, it didn't touch the runway. Visually, the visual field was challenging, and I thought it was further off the ground, and I actually crashed it right into the ground. And I thought, gosh, I wonder what my boss is going to say. I wonder what's going to happen. And luckily, my supervisor, another coworker, the first thing they said after I crashed it was this: build it, fly it, crash it, rebuild it, and fly it again. And that's a cyclical approach that I have thus far taken to approaching any type of RC helicopter technology, and then drones. And that was my first internship. I returned to NTID in the fall and decided that I wanted to become a cross-registered student because I knew what I wanted to do. I did want to complete my associate's degree. My internship had taught me so much. I decided, though, that I was ready to go on to my cross-registered classes. Before I graduated, I was at a point where I really was finished with my coursework, and I had the decision of staying here or going home. And so I decided to take a CIMT course, and I'm just going to briefly mention it because that course had an impact in the 3D technology I'm involved in now. I learned about the CNC machines, and I learned also about G-code, which is the code that you use to interface with the CNC machine. I did graduate that year with my associate's degree, and after I graduated, I was not yet matriculated into the bachelor's degree program at that time, but strategically, I knew that that program was going to require 5 co-ops. I was a student here under the quarter system, and I know the semester requirement might be different. I believe it's 4 co-ops under the semester system, but under the quarter system, I knew I would be required to do 5 co-ops. And so I took advantage of the summer I had off and asked if I could return and co-op for a second time at SMAP. That device did not require any remote control apparatuses. It used a delta wing, and it was really the advent that this delta wing led into drone technology. And so with other students involved, we worked together to create this aircraft. This other gentleman in the picture's name is Justin. We were all summer interns, and we were supporting each other, brainstorming with each other, using these devices and these vehicles to take pictures, aerial pictures. We were trying to land our vehicles in soft grass areas so that we wouldn't have crash landings, but maybe minor repairs that would be required. And we did that throughout the summer. We played with the autocopter, but the autocopter was too big, and we wouldn't want to be using the autocopter for the experiments we were involved with on the UAH campus. We decided we could use that more in an open rural area, but not in the city on the university campus property. When I came back to RIT after my second internship, I got into the core of electrical engineering and mechanical engineering courses. And in my 4 circles of knowledge, I added 2 more. The second one being electrical engineering, and the third one being mechanical engineering. All the core courses in my degrees that I studied taught me so much information, troubleshooting techniques, electrical control systems, electron mechanics, and materials technology. Materials technology, I would learn later, would be integral in the 3D printing technology that I'm currently involved with. I don't know if anybody ever saw the Short Circuit movie, but I consider myself Robot 5 at this time in my life because all I wanted was more input. I wanted to learn so much more. There was so much information that was new. The following summer in 2009, I had my 3rd internship, and there we worked on multi-router drones. I had never heard of that before. Now, while I was here in Rochester, before I left for my internship, I think it was around finals of the spring quarter, I got an email from SMAP, and they said, do you want to work on multi-router drones? And I'm like, what are these things? So I had to look them up, and this was my reaction. I was like, very cool. I definitely want to work on them. So after I arrived at the University of Alabama, Huntsville, I did some more research, and I found, I did research mostly on the quadcopter, and depending on how you set it up, where you set up the fly body, it can rotate horizontally around the rotors. We had a Y3 and a Y6 copter, which sounds complicated, and by the way, yes, they are, but also we had hexacopters that we worked with. The body was even more interesting. There were more options, and each of the different copters affected the performance. And so in my 3rd summer, right while I was doing my finals, I can remember, I don't even think I studied for the one final because I was so interested in researching the multi-rotor drone technology. I was very excited about all of these different copters. And then I found out that the largest copter at that time was the octocopter, which had the 8 frames, rotors, and motors. And this picture shows the many degrees of freedom that there are. There's the Z, which is the up and down, the forward and back movement, and then the left and right rolling. You've got the yaw, which goes laterally, and then the roll, and then the pitch as well. So if you're using like an RC controller, you have to think kind of in the opposite frame of mind because the actual vehicle will be traveling opposite to where you think it's going. And here's a picture of one of the drones we worked on. You can see the camera in the picture. It was very cool because we took area photos while we were controlling the vehicle all at the same time. After I built it, I wanted a Y6 because I heard that they were very difficult. Did some experiments with the Y6. The Y6 depends on how you write the code for it. So after this, I tried it, and this was the result, a crash. And I thought, oh, bummer. And as my coworker had said, fly it, crash it, rebuild it, fly it again, because through that process of trial and error is where you do your best learning. My 4th internship, and this is while I was still a student at RIT, was again at the University of Alabama, Huntsville, and that's when 3D printing technology was being introduced. And as I got into my 4th internship, there was a box at my station. It's pretty heavy. As I started to open it, my supervisor was there, and he said, "This is your summer assignment. You figure it out." And he walked away. So as I opened up the box, I saw documentation like is on the screen in front of you. And as I leafed through the documentation, I had no idea what it was talking about. And then I got to the page where it talked about 3D printing. And my boss had told me I had up to a month to build this, and I did it in a week. My boss was like, "Hey, slow down. I don't have anything else to give you because I thought this was going to take you a month." But it was fine. I mean, I learned through building the kit. I learned about 3D modeling. I learned a lot of knowledge here at RIT that then I could apply there. And remember, I talked about the CIMT class that I took. It taught me about G-code, which helped me with the 3D printing technology as well. After my first attempt at printing, this is the result. It looked like somebody vomited. That didn't come out very well. And I was thinking, what did I do wrong? And all summer I spent experimenting with this technology through trial and error. And my supervisor was right. He did keep me busy the entire summer. And I didn't work on just 3D technology. I worked on other drones and copters as well, while also focusing on 3D technology. My final internship, which was the final one for my degree requirement, Huntsville and SMAP. I had learned a lot about the multi-rotor vehicles, and the previous internships we used metal frames, and if you just have a minor accident with the frame where there's a slight bend, the vehicle will not fly as expected. And so even though maybe a drone wasn't crashed, it could be the fact that when the frame is bent, you can't fly it anymore. So these drones in this internship were made from polyamides. This one in this picture is one of my favorites. It's big. It's a badass copter. And I just had a lot of fun flying it around. It could lift heavy weights, and I had a lot of time playing with it. I could control it with my iPad. I could send it far distances. And one of the times, it was in the summer, I'll never forget it, I had students out, and it was like a runaway drone. And I was like, it's a runaway drone. And I asked the student, is it still in the air? And the student's like, yes. And I go, what direction? And he pointed in this direction. I'm like, well, where did you send it? And it was nervous laughter, but we weren't sure which drone in the sky was runaway. And we were trying to figure out the wind direction and the weather and how the drone was going to behave because we had lost control of it. So we conducted a search party to try to find this runaway drone, and we finally found it. Oh no, this is what it looked like. It finally ran out of battery power and crashed into the ground. Before crashing into the ground, it hit a tree. And I'm happy that it didn't go out into the highway or into traffic. We're grateful that it stayed on our property. However, with the drones and the crashes, you need replacement parts. But the replacement parts, it was hard to find that particular year because drones were the newest thing in town and everybody wanted to buy replacement parts. And you couldn't buy them off the shelf, you had to order them, and to order them would take 4 to 7 weeks. And students on intern can't wait 4 to 7 weeks. They want to be crashing the drones more often than that. So we decided to challenge ourselves, and I particularly looked at the opportunity to apply 3D printer technology. And we made a design, put it through the printer, and it worked. The bottom design was created by the 3D printer. The top design was one that we would have ordered through that 4 to 7 week process. After that final internship, I came back to RIT. And graduated. Well, I graduated, but I had to stay for one final quarter. And I asked if I could go to the University of Alabama at Huntsville. And they quickly invited me back. They said we had a lot of leftover drones on the shelves, spare parts everywhere. So I was able to go back and fix a lot of the drones using 3D technology. Going back in the summer after I graduated, they hired me and promoted me to a research assistant. The printer that they had provided me, I just felt was not accurate enough. And maybe that was the technology of the day, but I wanted to challenge myself to figure out what the hardware problem was or what the software problem was so I could improve the accuracy of the technology. And so I started troubleshooting. And I decided that I would test it with different materials. We tried woods, some flexible woods, did a lot of research over that summer, did a lot of training, used a lot of different drones, had several runaway drones once again. We had to repurpose and reprogram them all so that they would stay in the same area if they were to run away and lose control. What we did was we put a GPS chip in them so that there would be a memory for the drone. It was kind of like fencing the drone in an invisible fence. The GPS wouldn't allow it to go beyond a certain point in space. And so that was good training for the students as well as keeping the community safe. And we did this one at a time. We tried different approaches with each of the drones and each of the copters, and we also used FPV, the first person vision type goggles, where you have a screen overlay in the goggles that you're looking at. And so when you put the goggles on, it's as if you're in the drone flying. And people use it, they play, with their own choppers that way, but we were using it, and I noticed something wasn't right when I was using these glasses. The controls just weren't correct. And when I was looking at the altitude numbers, it seemed to be going faster, and before I knew it, I had to take the glasses off and look at the reality that was in front of me, and I told everybody, "Get under this tree now." I screamed at them, and again, the drone was out of control. I took my hat off. There was nothing I could do. People were looking up in the sky trying to find the drone. And before you knew it, everybody was still looking, and it came crashing down. It broke into many, many pieces. The battery flew out, bounced around, and pieces were everywhere. Everyone was looking at each other, but we were all laughing because they knew our famous quote, "Build it, fly it, crash it, rebuild it, fly it again." That quote will live with me and continues to live with me. So we collected the many pieces from this drone, went back to the office, and the students asked me, "What are we going to do?" I said, "Well, we're going to redo it. We're going to rebuild it." And they said, "With all these parts?" And I said, "Well, it might need a new body, but we can look at the parts and see what we can salvage and reuse again." Now, that summer, we were developing at the University of Alabama in Huntsville, we were developing some student projects. And these students are in this picture. They were all part of a magazine article that was featuring the drones. And this one student had a 3D scanner, and he wanted to work with us. So we thought that would be fun. What could we do with the 3D scanner? And he said, "Well, we could do anything." And he said, "Like what?" And so, the Xbox, the Kinect game, we were figuring out how we could use that technology to use the 3D scanner and to actually produce a character's space, character in 3D space. I used the G code to help implement this, and we were able to print it. And here's this kid out of a 3D printer. The technology is so cool. That summer was so exciting. I did come back to RIT in the fall quarter to finish my final requirements for the bachelor's degree, and the only thing I could think about when I was here at RIT was to complete all my courses in the fall and have that be my last quarter. And then I returned to the University of Alabama, Huntsville after my final quarter and was hired as a research associate. I've been involved in researching 3D printing technology. I have a notebook full of notes. Notebooks are very important because as you learn new things, you can jot it down, take off, come back, and then refer back to where you ended your last experiment or whatever you were researching. So at the beginning of 3D technology, I have a passion for starting things from scratch and building things, things that I find, rebuilding and repurposing things. The first thing I did was to take this apart. This is the heat bed right here. I took that off because I wanted to keep that, but I wanted to see structurally what was in the printer. And then this is an improved version with a different surface. You print right on that black surface. And there are a variety of materials. Each material has its own characteristic. Some materials will not accept heat, others will, and so you really have to know the materials that you're going to implement and use in the printer technology. And I'm so grateful to RIT for the materials technology courses that I took, and thankfully I kept my textbook from the course that I took here, and although I sold many books back to the RIT bookstore, after returning to Alabama in the winter and then in the spring, I did research, and then in the summer, there was an undergraduate senior design group that had contacted our department. They said they were interested in the resources we had related to 3D printing, and they referred that group to me. And as I interacted with the students, they were all hearing, and I was deaf. And let me just talk about me being a deaf person in a hearing world. I don't start off with, hi, I'm the deaf person working with you. Usually I meet people through email, and we start to make our connection through email, because I've noticed if you lead off by, hi, I'm deaf, behavior changes immediately. So I've stopped leading off with that introduction, and I've gotten different reactions, because when you introduce yourself via email, they treat you just like everyone else. And so when they came to meet me in person, I decided I wanted to break the ice before they could even have a chance at being shocked. So I handed out paper and pencils, and so I said, I want you to write down your goals for your project. Write down your goals and how I can help you, the undergraduate students, in your design project. And my goal is that I wanted to provide all the resources that I had available to them in their senior design project, and I wanted to advise and partner with them as best I could. It was a very successful design project, from proposal to the actual project. Here's a picture of that tethered vehicle. It's not battery operated. It could go and then stay on the tether. It's kind of like a weather balloon, but they wanted it to be able to lift a heavier payload than a normal balloon would. So if they were to add a battery, that would weigh down the balloon. So they figured out a design that would allow this vehicle to hold a 10-pound payload. If you're going to use a balloon to hold a 10-pound payload, it would have to be a very large balloon. And weather balloons are not cheap. After I helped the senior design product team and their accomplishments, then in the summer, I was contacted, I had interns come and work under me doing a variety of projects. And one of the largest projects that we did in the summer was the one that's on the slide, the virtual Alabama Jackson County School Safety Initiative. A client contacted us. The school system wanted to partner with us, and I asked him what the actual goal was. And from the goals and requirements of the client, I then used my interns and parsed the work out. We used a hexacopter and a quadcopter. We worked with 18 different schools and took aerial photos of 18 different schools during one summer, one internship. So we'd go to 1 or 2 schools a week. We were constantly on the road, taking schools pictures, and the interns had a great time, as well I did. And the summer is incredibly warm in Alabama. It can be near or over 100 and very humid. And we worked in our flip-flops and had our FPV goggles on, and we worked in the hot summer. And I already knew the weather would be incredibly hot, and so we used our time well. People often ask me, how can you actually see the movement? And what happened is I used my iPod as well. The iPod can connect and give me feedback as well. And so with the iPod, I can tell the camera at what points we want the pictures. But we also had a manual override in case something went wrong. If the computer had a glitch or if the GPS was not acting accurately, then we could use our manual overdrive. But all in all, at the 18 different schools, one of them, a hawk, caught our drone. We were flying it, and we saw something in the distance. And as it got closer, then I was wondering, is that a hawk? And the hawk was going to attack my drone. And as it got closer and closer, it caught it, and then it dropped it, and it freaked me out a little. I mean, I don't want to hurt the hawk, but I don't know why it was chasing my drone. I was trying to get the drone back. I was trying to, give it the command to fly home, but the hawk flies pretty fast. So I didn't want the hawk to hurt my drone, and I was telling the hawk, I care about you. I don't want to kill you, animal. Finally, the hawk recognized me, I guess, and it took off. But the hawk really messed up my schedule for the day. And then I thought about it. I wasn't sure if I did catch it on video, and I reviewed the video that I had for the day, and unfortunately, the hawk was not in any of the video shots that I had. Now, our department likes to use the aerial technology, and we will upload the aerial photos we have. So this is one of the schools out of the 18 that we originally the satellite imagery tends to be 2 years or 3 years behind, and our client wanted up-to-date photos. In the summer, the client wanted to see accurate, real-time information. And so the school districts and the administrators wanted to make sure that the information was accurate, and everyone worked together to make this happen. And so you can see the different photos, and you might notice the different colors and shades, and it's because of the way the sun was interacting with the pictures on the day that we were taking it. Even though we took the pictures all maybe on the same day, cloud movement affects the photos that you get. One of the teams did a 3D model of one of the buildings in the pictures. And we did, like I said, 18 schools. I have another school that I can show you. And this was an example of one of the drones. This was actually the drone that the hawk almost got. Interesting, we learned about how the wind really affects these drones, which means that aerodynamically they need to be fixed. And so we looked at the quadcopter from DJI. You can buy a ready-to-made kit for one of these copters. Unfortunately, the camera is fixed on the bottom, and you can't stably move it. And so with a 3D printer, we were able to fashion a gimbal, which allowed us to do that. And we made this with our 3D printer. and then we put it on the bottom of that quadcopter, and now our camera was mobile. I decided to start my HCI master's degree because people would ask me about myself. Who are you? You know, yes, I'm a electrical engineer, I'm a mechanical engineer. I've studied these different areas. But when I started the master's degree in human-computer interaction, at the center of who I am and all that I've learned and all that I've become, the yellow is who I am, and I consider myself at heart a mechanic. SMAP moved into a new building. We were in a small building for those many years. And with the drones, we had the drones literally hanging off the ceiling. So we moved into a new building, and then, well, didn't really want to mention the FAA, but they do impact our work. And for years, we could fly freely until most recently the FAA has made some rulings. They've put limits on how far you can fly and how high you can fly and what type of rules and certifications you have. And it has impacted our department and will continue to impact our work in the future. The FAA, if you don't know who they are, is the Federal Aviation Administration. It's a federal agency. People who are against the FAA regulations say that drones can have internal programming that will block the airplanes so that there won't be an issue with airplane and getting into airspace. But you have to think about the FAA has to manage commercial use as well as hobby use. And so this is new terrain for everyone. I don't know if you've heard about what happened at the White House. It was not one of our runaway drones from Alabama that caused the White House incident. But there were a few spots in the Washington, D.C. area. I believe there are 3 major airports in the Washington, D.C. area. And their airspace, once their airspace was invaded by a drone, there was an immediate FAA response, and they drew this circle around the Washington, D.C. area that has restricted the airspace. And you think about the poor hobbyists who live in that area and the kids who want to buy drone kits. They can't even buy a kit to go out in the backyard and fly at a few feet. That's banned airspace. So our department is suggesting that we have they set up a certificate for researchers and people who would apply for this certificate to be able to fly drones in their airspace. And that is going to be an ongoing fight. So in the past, you can see we're at Huntsville, you can see the rocket there, that's on NASA's property. Our drones could fly over the city. We were free. Now, after the FAA ruling, in order to meet their guidelines, we're tethering, or we're going to have our drones fly in an enclosed airspace, which is not the optimal flying environment. If you're tethered, the drone will not fly naturally. And when you think about, drone technology, I mean, we have in the parking lot, if you want to put up a fence, then you're going to be taking those spaces, but we could, raise our hopes if we could maybe enclose it, but the FAA has these restrictions on where we can fly. And so, because we have to be either encased or tethered, this is our new future, flying in this type of a setup. got all excited one day. And so most recently, this previous summer, I was in the media at the university, put its attention on me specifically, working in the lab. Unexpected. I was training students working with me with drone technology and 3D printing technology. I was focused in the media, and ever since then I've been involved in a lot of different research projects. This robot and its parts were mostly made from 3D printers. The frame is strong because of the way the wheels are made. Again, strength of materials is very important when you're thinking about the materials you're going to use to build the body of a robot. You want to build the robot so that it will work, but you also want to build the robot for its durability. Just like when you're working with a client, you need to have a pencil with a very big eraser because clients change their specs and their minds and what they want and what they don't want quite frequently. And so you're constantly writing and rewriting requirements from the client's point of view. And so you realize how much a challenge that engineering is. I also wanted to get involved with something different. And again, looking at 3D printing capabilities, I was thinking about a Mobius strip gear. There were people who were designing it, and they had wanted to have it designed and then start the printing. And so we altogether printed 11 gears, but the question for me was this gear set actually accurate? Here it is, printed, and you can look at it afterwards, and you can pick it up. That will be fine. You can look at it. I wanted to print a little dragon, just a small kind of knick-knack side. I wanted to see if I could make the shape in a 3D printer. The robotic hand. I saw that RIT had that project Enable that was helping people who needed a prosthesis. So I was investigating in the community what I could do. These are all pieces that were made separately, and you can see the pieces are grouped. It's very cool stuff. I wanted to study the shape of the human hand and see where movement is limited. You can't really put your fingers together and spread them apart. You can touch the thumb to the center of the palm, however, you can't rotate the thumb around. And I was researching how we could make the hand as human as possible. I can make it happen. I can make it fingerspell the manual alphabet in ASL, but we are limited in our degrees of freedom. And also I added a grasping. I added some textural on the palm to help it grasp. 3D printing we've also used for the College of Science. They wanted me to print out what skeletal bones actually look like. I did that. The College of Engineering, a graduate student group, approached me, and they wanted to use my printer. So we talked about what their needs were. I found out what their goals were. Talked about what their plans were. They wanted to figure out a flexible material that they could use in healthcare. So this took about 7 hours to make. Altogether, this took about 2 days to make all its parts individually. And then It's called a CubeSat, and they plan to put that in a rocket and send that into space. And then I was like, I don't know if they're really planning on sending it into space. I don't know what their plans are for the future. I just gave them what they requested, but when I looked into it, that's what it said these boxes are used for. This next crossover project I'm still working on. I have a lot of drones that are sitting in our office. They've all been crashed. And although they can't fly, many of the parts that are still a part of these skeletons are usable. And I believe in recycling and repurposing. And so DJI Inspiron is the crossover project that I am working on. This is a picture of the shelf in our office space with all the crashed drones. Again, the parts, many of the parts still are able to be used, and I pick out my personal favorites to hang from the ceiling. Here's a lot of copters that the bodies are no good or their frames are bent. But again, we can use a lot of the electric circuits and the other parts that are still usable, we can take from those drones that have crashed and reuse them. When I got involved in some of the 3D printing forums, we were talking about the DJI project, and people talked about how expensive it is. And if you buy this specific drone without a camera, it's about $3,000, which is quite expensive. So I thought about maybe I could make it, but in a scaled down version. The DJI one is approximately 1.5 feet, 2 feet wide. And so with some people in the community, I opened up a conversation and gave each other feedback, and we settled on this design that's on the slide because the drone can pull in its feet. We want to give it plenty of room for the camera to be able to take pictures in a 360-degree view and allow the drone to pull up its legs so that the legs will not interfere with any of the pictures. So with the 3D view, we had to make sure that the parts will actually allow the drone to move as well as the camera. And once we had the design where we felt it was right, then I went ahead and printed all the parts. It took about 3 weeks to print all of the parts, and here they are being assembled. These two parts are for the ball bearings. And then this is the outer casing of the body. I used carbon fiberglass arms, and that was the one thing that I could not print using the 3D printer. 3D printers cannot print with carbon fiberglass, but this is what the drone looks like, made from a 3D printer, except for the fiberglass arms. This is still considered a prototype. It is still a rough draft. Hopefully we'll be doing some testing in the next month or so. I have another project that I'm doing on the side, and we're not really in a rush to do it. As I can attend to it, I will. But it is the Delta style 3D printer, and its connections can move in a circular way because that technology allows it to actually print the object that you're printing faster. The firmware and the hardware still have some issues, and we're still working on that, but the Delta style 3D printer is one of my ongoing projects. And here's an example of it. It's taller than I am. Pretty tall. We're getting close, but we're still working on this. Not to mention, I have this other project, the 3D printer web server. I am getting tired of going and making sure that everything is running right on the pre-D printer. From home, I can get a page if something's going wrong, but I'm not exactly sure what's going on. So then I'll have to physically drive into the lab and find out that it really is just a little thing. Maybe a person's in there working and they smell something and they're not sure if something is wrong with the printer or not. And so I'd like to set up a centralized control system within the 3D printer to handle that kind of communication. And this would be a raster card type of assembly, a server that if you wanted to purchase the server space, that would be more expensive. So instead, if we set it up using the 3D printer, here's a picture of it. This is cool. It's a 3D printer web. I can be at home, pull this up on my computer, and see what's going on. So if something stops, if there's a change in temperature that's going to cause something to not work in the printer, I can pull it up. I'll be texted to say there's something going on, maybe the temperature's not right, or power has been lost, or whatever the incident is, and then I can pull it up and look at it. And so I can be at home, checking the 3D printer, making sure all is well, and then I can go back to bed, and I don't physically have to leave my home in order to check on the 3D printer. And so this information is being sent physically from the printer through technology to me, and then I allow other students who want to learn about 3D technology as well. I give them the authority and permission to use that because I want them to be under maintenance as well, so they can be on where it says under maintenance. Some students then will send a message, and if it's serious enough, it will say ask Stephen, and then once they get my okay, then we can run the printer again. Oh, this is an exciting part of my job. My job is not just about the daily work, projects, and research I'm involved in. Another exciting part of my job is No Voice Day. We have this every month for one day. All the students have decided that we should do this, and we set up No Voice Day. And they were shocked in the beginning. It's a lot of fun. And I said, you don't have to do this. It was just a joke, but we had good fun with it. You know, the students did put earplugs in. And when it was time to go out to lunch, the students started to take out the earplugs, and I'm going, it's No Voice Day. So I said, now you can see what it feels like to be in my shoes as we interact in a restaurant and order our lunch from a waiter or waitress. And so the students, the waiter and waitress, went to each student and got their order. And philosophically, No Voice Day has really improved everyone's ability to sign. A student has come to me and said, do I have to learn how to sign? And I go, it's up to you if you want to learn how to sign. And the student said, should have No Voice Day for a week. And I go, it's up to you. We're going to set it up once a month, but it really is up to you. I'd like to talk about STEM and the outreach we do. I was a speaker at Deaf Space Camp, gone to the Alabama School for the Deaf, also Bellevue State Community College. I've also been invited to Jackson County Schools. As we did the aerial photos, many of the schools invited me to come and do demos And then while we do demos, we talk about STEM education as well. I talk to them about the awesome world of STEM education. And I have many other things on my list at work. So in my 4 circles of knowledge, I realized that I am a Medtronic, which is the core of the robot. The robot is an electrical system, it's a computer, it's a physical frame, and that's who I feel that I am. So that's about me. Thank you very much.